Hi everyone, in this video I will talk about the arithmetic, which is one of the parts that is included in GAT test and worth about 36% of the test. So in this slide as you can see, we have the special numbers like odd number. And the odd numbers are the numbers that are not divisible by 2. For example, we have 1, 3, 5, 7, and so on. Also, you have to know what does it mean even numbers, and even numbers, all the numbers that are divisible by 2. Let's see, we have 2, 4, 6, and so on. Also, we have the prime numbers. The prime numbers are the numbers that has only two factors, 1 and itself. So 2, 3, 5 are all prime numbers. We have also the composite numbers. The composite numbers are the opposite of the prime numbers. So any number that has more than two factors would be composite numbers. For example, 4 is a composite number because it has three factors, 1, 4, and 2. The integer numbers are 0 and all the positive numbers, and also the negative numbers. Okay, we have the real numbers, which is the largest group that we are dealing with, and we have the natural numbers. The natural numbers, it is the numbers that, for example, 1, 2, 3 is the first group that human deal with. So 1, 2, 3, 4, and so on. Then we have the rational number, any number that can be written as a fraction, a over b, it would be a rational numbers. Okay, we have also the irrational numbers. So if you couldn't write the number in this way, it would be irrational numbers. For example, root 2 or pi are the irrational numbers. The last kind is the recurring numbers. There are some numbers are repeated in a specific way after the decimal point. For example, 1.3333, okay. Or for example, we have 1.323232 and so on. Okay, now let's see some examples about this. We have compare between value A and value B, and here, as you can see, you have three numbers, three negative numbers multiplied with each others, but here we have two negative and one positive. So it is not practical that you just multiply the numbers together to get the answer. But since you have a minus and a plus, so if you multiply three negative numbers together, you will have a negative answer. But if you multiply this negative with this negative would give you a positive, then a positive times a positive would give you a positive. So this whole is positive and this whole will be a negative. So comparing a negative value with a positive value, the negative value is less than the positive value. So value B is greater. Okay. Okay, next question, also compare between these two values if x equal 1.5. So the same way, you can of course just substitute the value of x in the value of a and then find out the answer, but this would take long time. So it's better for you just to do it, to use a mental math. Now you have 1.5. So if you subtract 1.5 from 1, this would be positive because 1.5 is positive. So positive minus a value that is less than, okay. So here, let's say, for example, large sorry. So if it's positive, x is larger than 1, x is larger than 1. So if we subtract x from 1, it would give me the sign of x, which is positive. Okay, so this would be positive. Now here, 1.5, our x would be less than 2. Okay, so this would be negative. And also here, 1.5 is less than 3, so the answer would be negative. Now we start to find out the product. So plus times minus would give us plus or positive. Let's try this also, this technique in value b. So 1.5 minus 1, 1.5 minus 1 also would give me a positive value, and here negative value because 1.5 is less than 2, and here positive value. If we multiply those three values together, plus times minus is minus, and minus times plus would give me negative. So comparing negative value with positive value, of course the positive value is larger, so value A is greater. Okay, now we have the divisibility rules. In the divisibility rules, you have to know the most popular numbers, the rule of the most popular numbers, the divisibility rules. Okay, and let's see the first one. When the number is divisible by 2, the number would be divisible by 2 if it has if the last digits or the ones is 0, 2, 4, 6 and so on. So basically if it's even, so if it's even, it would be divisible by 2. Okay, the number would be divisible by 3 if we add all the digits together. You will have a number that's divisible by 3. Let's see times table 3. We have a 3, 6, 9, okay. Then we have a 12, 15, 18. Then we have 21, 24, 27, and then 30. If you can notice, if we add these two together, we would have 1 plus 2 would have 3, and here 1 plus 5 we will have 6, and here 1 plus 8 will have 9. So we repeat, we're going back to the same three numbers. Also here, if we add this, we will have a 3. If we add those, we will have 6. Then we will have here 9. So again, 3 is 6, 9, and 3 plus 0 is a 3. Then if you complete, you will see you will have also 3, 6, 9, and so on. So this, if you go to the times table 3, you will see how it's work, or how the rules is working here. So you have to add all the digits. If you add the digits and it's give you a number that is in times table 3, or basically 3, 6, 9, the number would be divisible by 3. Okay, let's see. Let's see the divisibility by 4. And the divisibility by 4, the last two digits is divisible by 4. Okay, so if you get a number, for example, 16616, this is divisible by 4. Why? Because the last two digits are divisible by 4. Okay, so we always focus on the last two digits. Okay, and divisibility by 4, the similar to divisibility by 4 is divisibility by 8, but here we consider 3 digits in the 8. We consider 3 digits, while here we consider only 2 digits. Okay, and also the divisibility by 3 is similar to the divisibility by 9, but here we after we add the digits together, we have a number that's divisible by 3. And 9, after we add the digits, we will have a number that's divisible by 9. Okay. Also, we have something similar. The divisibility by 6 and the divisibility by 12. Okay. And divisibility by 6, it should be divisible by 2 and 3 at the same time. Okay, so if we said, for example, 12 is divisible by 6, and we know that because 12 is 6 times 2. So 12 is divisible by 2 and divisible by 3 at the same time. That's why it's divisible by 6. Also, if we got here, for example, 24, and we know that 24 is divisible by 12 because it is 2 times 12. It should be divisible by two numbers, 3 and 4. And yes, 24 is divisible by 3 and divisible by 4 at the same time. Okay, so now what is left? Let's see here. We have a divisibility by 10. And divisible by 10, divisible by 5 is a little bit similar because we are looking at this last digit, and the last digit should be in 5, it should be 0 or 5, and in 10 it should be 0. And you can memorize that. When you look at the times table 5, you will see that all the numbers has the ones digits of all the numbers is either 5 or 0. Okay, as you know, the times table 5 is 5, 10, 15, 20, 25, 30, 35, and so on. So if you notice the last digit, you will see it's either 5 or 0. And also in times table 10, it is 10, 20, 30, 40. So the last digit always 0. So this is the rule of the divisibility by 5 and 10. Now we have left the divisibility by 7 and the divisibility by 11. And the divisibility by 7, we have, let's see here. I'll give you an example. If we have the number 49, you know 49 is 7 times 7. Okay, so we double the last digit. The rule says we have to double the last digit, then we minus it from the rest. So if we double the last digit, 9, double of 9 is 18, then we minus it from the rest, which is 4, we will get 14. And you know that 14 is in times table 7 or divisible by 7. So the rule is to double the last digit, then minus it or subtract it from the rest of the numbers. Okay. Let's see the rule of 11. The rule of 11, for example, if we have 1 to 1, you know that number is divisible by 11 because it's 11 times 11. And to apply the rule, we have to subtract the last digit from the number formed by the remaining digits. Okay. So we're going to add these two digits together, which is 2, then subtract it from these two digits. Here we have nothing, so we will subtract it from 2, we will get 0. So it is divisible by 11. Okay. What is the number that if divided by 7 would be 9 with the remainder 5? In this kind of questions, we can directly times 7 with 9, okay? Then we add the remainder, which is 5. So this would give us the number that the question asks for. So 7 times 9 is 63 plus 5, which is 68. So the answer is 68. Okay. Which of the following can be written in the form of 3m, where m is an integer? So since it can be written as a 3m, so the number should be divisible by 3. And we said before, the divisibility by 3, we have to add the numbers all together, and we'll see if the sum is divisible by 3, so the number is divisible by 3. So if we add those numbers together, 2 times 4 equal 8. So this number is not divisible by 3. And here we have 1, 2, 3, 4, 5 of 2. So 5 times 2 is 10, also not divisible by 3. And here we have 1, 2, 3, 4, 5, 6. So we have 12 numbers. 12, the sum would be 12. And 12 is divisible by 3. So yes, this is the number. Okay. And here we have the least common multiple and the greatest common factor. So in the least common, the greatest common factors or the least common multiple, we have to factorize the numbers that we have. Okay, so if we factorize 60, we will have 2 to the power 2 times 3 times 5. And factorizing 72, we will have 2 to the power 3 times 3 to the power 2. Now, to find the least common multiple, we just have to take the all the factors. Here we have 3 numbers, so we're gonna take 2 and 3 and 5, but for the least common multiple, we will take the highest power. So 2 to the power 3 and 3 to the power 2, and then times 5. So we will have here 8 times 9 times 5, and 8 times 9 times 5 would be 360. For the least common multiple, for the greatest common factors, we will take only the common numbers. We have 2 and 3 in common, and we will take the least power. So 2 to the power 2 and 3. 2 to the power 2 is 4. 4 times 3 equal 12. Okay. Let's have an examples about this. We have a letter that we can climb 6, 6, 8, 8, or 10, 10. Which of the following can be the lowest number of steps? Okay, since the letter we can divide it to 6 steps, or 8 steps, or 10 steps, so the number of letter could be should be divisible by 6, 8, and 10. So we're going to try the options that we have, or also we can just find the least common multiple. So the least common multiple of 6, 8, and 10 could be found, as we said, by factoring each one of those. Okay, so 6 is 3 times 2, 8 is 2 to the power 3, 10 is 2 times 5. To find out the least common multiple, we will take, as we said, we will take all the numbers that we have. So we have 3, we have 2, we have 5, and with the highest power. So since here we have 2 to the power 3, so we'll take here 2 to the power 3. Okay, 8 times 5 is 40. So here, 3 times 40, and 3 times 40 is 120. So the answer is 120. Okay. The rectangle dimensions are 330 to 220. So imagine something like that. Here is 330 and here is 220. What is the length of the side of the square used to cover the rectangle area with the fewest possible numbers of squares? So we want to divide this to number of squares, and we want to know how many, we want to know the length of the square. So I want to know this this one. Okay, so in how many parts should I divide 2020, and how many parts should I divide 330? So I'm going to use the greatest common factor in this way. So let's find out the greatest common factor for these two numbers. So as we said, we have to factorize both numbers. You know that 33 is 3 times 11, and then we have 10, which is 2 times 5. And here we have 2 times 11 times 2 times 5. Or I can write that as 2 to the power 2 times 5 times 11. And here 3 times 2 times 5 times 11. So the greatest common factor, we said we only gotta take the common factors, exactly the common factors, which is 11, okay, here and here, and 5 also here and here, and 2 here and here. So 11, 5, and 2, and the lowest power, so I will not take 2 to the power 2, I will take 2 to the power 1. 2 times 5 is 10, 10 times 11 is 110, so this is the answer, 110. Okay, that's all for this part of arithmetic. Hope you like it and you understand. Thank you for watching. Bye bye.